Let's go over the second graphing example. This time we have a linear function over linear function. Hold on, let me show you what the function looks like. So f of x is 2x plus 3 over x plus 2. So we want to graph this function by first start by drawing all asymptotes. Let's start with the vertical asymptote, okay? So on the side over here, let's write down that we want to find the vertical asymptote. Some of your homework problems in Alex this week simply ask you to draw asymptotes. In those cases, you don't really have to graph the function, you just sketch the asymptotes. So how do you find the vertical asymptote? You set the denominator equal to 0. That is what you do. So the denominator of this function is x plus 2. So you set this x plus 2 equal to 0. But we have to be very careful, guys. Remember, we talked about how it has to be the 0 of the denominator, but it cannot be the 0 of the numerator at the same time, because if that happens, like remember we talked about that in class. Another example that I'm just making up right now. Say that you have something like this. The only vertical asymptote is at x equals 5, not at x equals 2, because if that happens on the numerator and the denominator, whoopsie, let me zoom out, then what will happen is they will cancel out and that will actually create something called a hole. Okay, we're actually going to look at that example in the probably example 6 or something like that. But I didn't have to worry about that because if you look at the numerator, the 0 of the numerator is, if you try to solve for the 0 of the numerator, that's going to be negative 3 over 2. And that is not the same as what we are about to get over here. You see the vertical asymptote that we are getting is x equals negative 2, right? So because that's different, that is a vertical asymptote, okay? But we will see when the 0 of the denominator is simply not a vertical asymptote, but it can be called a, what's it called? The whole of a function. So plot or graph x equals negative 2 with the dotted line. So I'm going to go ahead and use a highlighter and draw a dotted vertical line at x equals negative 2. That is going to be our guiding line when we graph this function, okay? All right, let's go on and find the horizontal asymptote. Horizontal asymptote. And remember, from our class discussion today, we must look at the degree of the numerator and the degree of the denominator in pre-calculus class. We don't do limits just yet in this class. So if you look at the degree of the numerator, it is 1. The degree of the denominator is 1 again. So remember, if they are the same, degree of the numerator is 1, degree of the denominator is 1, what we have is n equals m when they are the same. And simply the horizontal asymptote will be the ratio of the leading coefficients. So if they are the same, we must simply take the ratio of the leading coefficient. So the leading coefficients in 2 and 1, we have a horizontal asymptote at y equals 2 over 1, which means y equals 2. So that is the horizontal asymptote. Because the degrees were the same, we simply take the ratio of the leading coefficient. Let's plot that, or let's graph that with the dotted line at x equals, y equals 2. Looking good. Does it have a slant or oblique asymptote? No. No slant or oblique asymptote because n equals m. Remember, for it to have a slant or a oblique asymptote, the degree of the numerator has to be bigger than the degree of the denominator by exactly 1. When they are the same, then it's not big, right? It's not. So when you have a horizontal asymptote, guys, you're not going to have a slant asymptote. So we have horizontal asymptote this case, so we're not going to have a slant asymptote. So we're ready to graph this function. Now we do this by plotting 2 points on each piece of the graph. So look at the red line. I need 2 points to the right side of the red line, and I need 2 points to the left of the red line. The red line is at -2. You see, the red line is at -2. So when I make my XY table, I'll just go ahead and try to pick some numbers that are bigger than -2 and smaller than -2. Okay? So what 2 numbers should I use? How about I use 0 and 1? I don't know. Well, I guess I can use -1 and 0. Okay, I'll use those 2 first. And what was the function? The function was to do 2x plus 3 divided by x plus 2, right? And guys, if you have a science graphing calculator, if you want to use the like table of value function, that's okay, but I'll just do it the old-fashioned way. I'll plug it in, okay? So y will be 2 times -1 plus 3 divided by -1 plus 2. I hope this number comes out to be nice. The numerator is -2 plus 3. The denominator is -1 plus 2. Hey, I'm sorry, that's the same thing as the before. Isn't that just 1? That's just 1, right? My 1's not pretty enough, 1. So if I simplify this, this will be 1 over 1. Hey, that is just 1. So I'm going to plot 1, 1 on my graph. Well, let me do one more. I'll plug in 0 this time. If I plug in 0, I'll get 2 times 0 plus 3 over 0 plus 2. Will that be a nice number? I will get 3 over 2 is not that nice. It is 1.5. I can plot 0 and 1.5. Not bad. Hey, I want one more because the last one is of decimal. I want one more. So if I plug in 1 this time, what will that be? And guys, this will happen when you're doing Alex homework, but Alex will let you type in these fraction values, so not a problem at all. So if I plug in 1 in there, will that be nice this time? That will be 2 plus 3 divided by 3, which is 5 over 3. This is not pretty at all. You know what? That's okay. On Alex, you should be able to click on, I think it looks like this, like a function that looks like this. You click on this, they will let you type in what you want to type in, what you want to plot. So I will type in 1, comma, 5 over 3, and they will plot that for me. And I will not put a decimal approximation because 5 divided by 3 is a never-ending decimal. So I even give up on this. I'm not going to plot this. I'm not going to plot that. I have 2 points. I will plot those 2. 1, 1 first. 1 to the right, up 1. Here's my first point. Oh, I'm sorry. Oh, I must made a mistake. Notice it wasn't +1. It was -1. Oh, thank goodness I caught that mistake. So go 1 to the left, go up 1. Here's my first point. Next point is 0, 1.5. 0, 1.5. And that's enough points. Because you see, my graph will be bounded in this red line and this black line. So guess what? My graph will look like this. I will connect these 2 dots, but my graph will go straight down as it gets really close to that vertical asymptote. And to the right side, this is going to just follow that black horizontal asymptote. Get really, really close to it. So that's the graph in that area. Now, I need 2 points to the left of -2. So I'm going to use numbers like -3 and -4, okay? I'll plug in those numbers. If I plug in -3 and -4, let's see if we get friendly y values to plug in. 2 times -3 plus 3 over -3 plus 2. That is -6 plus 3 divided by -1. Oh, I think this is going to be a nice number. Negative 3 divided by negative 1 is positive 3. So I will plot a point at negative 3, positive 3. Okay, next one. I have a strong feeling this will be an ugly number to plot, but I'll just go on. Because I noticed that on Alex, you guys can plot fraction values using that tool. So you check out that tool, okay? Negative 8 plus 3 divided by negative 2, which is negative 5 over negative 2, which is 5 over 2. So I will plot negative 4, 5 over 2. But to make the graph easier, I'm just going to convert that into a decimal. But that decimal will be exact. Half of 5 is 2.5. But if it's not an exact decimal, you will not plot that. Please keep it in fraction when you are graphing these on Alex, okay? But since I'm just doing this by hand, I just needed to convert it into decimal so that I know where this point is going to be. So first let me plot negative 3, positive 3. 3 to the left, up 3. Oh, it's on this area. And next one is 4 to the left, 2.5. 4 to the left, 2.5. So it's like right here. So I have two dots, and as you can see, these two dots are bounded by the red horizontal vertical asymptote and the black horizontal asymptote. So if I try to follow this graph, this will go straight up following the vertical asymptote, and to the left tail is going to come down and it's going to get infinitely close to the horizontal asymptote of y equals 2, but it's not going to cross it. It's just going to get really, really close to it. So that is it for example number 2. We found all the asymptotes. Let me zoom out like crazy. And we found 4 points and 2 to the each side, each piece of the graph. So that is how you can graph linear over linear case. Okay, let's go to example number 3 in another video.